Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Afrina Fatisha binti Johari. Today, my group members and I want to present about logical implication. First, I want to present about introduction of logical implication. Logical implication is a type of relationship between two statements or sentence. The rule of inference are fundamental in the development of a step-by-step validation of how the conclusion Q logically follows the premise P1, P2 and more in an application of the form P1 intercept P2 intercept others implies Q. The symbolic form for logical implication is P intercept P implies Q, which is P and P implies Q we call as premise and Q as a conclusion. And in the tabular form, P implies Q as a premise and Q as a conclusion of the statement. And then is rule of inference. There are a few rules of inference that related to logical implication. The first rule is modus ponens. The first premise is P and the second premise is P implies Q. So for the first rule, we can cancel out the statement P and the answer will be Q, which is the conclusion will be Q. And then the next rule is law of the syllogism. For this rule, we must cancel out the right side first for the same statement, which is Q, and then the left side. And then the conclusion for this rule will be P implies R, which is P will implies R, and the conclusion will be P implies R. And then for the next rule is modus tollens. For this rule, the first premise is P implies Q, and the second premise is negate Q. For this rule, we can cancel out the same statement, which is Q and Q, and then the conclusion will be the negate of P. And then rule of conjunctive. For this rule, the first premise is P and the second premise is Q, and we can combine two single premise and the conclusion will be P intercept Q. To combine two premise, we might use the symbol of and, or we'll call as intercept. The next rule of inference is rule of disjunctive syllogism. The first premise is P union Q and second premise is negate P. For this rule, we can cancel out the statement P and negate P, and the conclusion will be Q. For this rule, the first premise P union Q, the symbol we must use the symbol union, and then we can cancel out P and negate P, and the conclusion will be Q. And then rule of conjunctive simplification. For this rule, the first premise is P intercept Q. For this rule, we can choose whether the conclusion we want to choose the conclusion P or Q, but the symbol for the premise we must use the symbol intercept, and the conclusion will be the answer will be P, or we can choose Q. And then rule of disjunctive amplification. For this rule, we use to exist new premise which is P, and the conclusion we can exist new premise which is Q, and for the conclusion will be P union Q. We must use symbol union.
Alright, move on to example 1. So, the example 1 asks us to consider the following argument. That's reads, it's not sunny and it's colder than yesterday. We will go swimming only if it's sunny. If we don't go swimming, then we will take canoe trip. If we take canoe trip, then we will be home by sunset. So, for the question 1, in the example 1, the question asks us to declare all the primitive proposition in the argument into the symbol that has been given by the question, which is P, Q, R, S, and T. So, after we done reading the argument, we can say that P, it's sunny this afternoon. Q, it's colder than yesterday. R, we will go swimming. S, we will take a canoe trip. And T, we will be home by sunset. and that's the answer. So let's do the question 2. Question 2 asks us to write a premise of the argument by using the symbol that we write in the question 1. What we need to do is to read the argument one by one and transform it into the symbol that is searchable by its argument. So for the first argument, it reads that it's not sunny and it's colder than yesterday. So it's sunny this afternoon is P and it's colder than yesterday is Q. So we simply need to write P and Q, but it reads that it's not sunny, so we can assume by the word not that it needs to write a not symbol too. So it will be not P and Q. For the second one, it's read we will go swimming only if it's sunny. So we can assume by the we will go swimming that it is R, and if it's sunny, if it's P, because the P reads it's sunny this afternoon. So it used the symbol R and P, but it has the words only if. So we need to write R implies P. So for the third argument, it reads that if we don't go swimming, then we will take a canoe trip. So if we don't go swimming, so by the word swimming, we already know that the symbol is R, and we will take a canoe trip is a S symbol. So we already know that two symbol that being used is R and S. But if we read carefully in the first one, if we don't go swimming, it has the word don't. So we need to use the not symbol. So simply we need to write not R imply S. For the last argument, it reads that if we take a canoe trip, then we will be home by the sunset. So if we take a canoe trip is S symbol, and we will be home by sunset is T symbol. So by the wording if, we already know that it will be used implies. So we need to write S imply T. So that's the answer. And for the last one, we will need to write therefore unknown, since we did not know the conclusion yet. So for the question 3, which is the last question, we need to prove the validity of the argument by using the rule of inference. So to do this, we need to use the premise that we do in the question 2 before. So the first step, we need to take a first premise, which is not P and Q. So and then we simply need to simplify it using the simplification rule, which we will get not P. After that, we take the second premise, which is R implies P. Okay, look, if we take a closer look, before we get the not P, and right now the premise is R implies P. So we can use the modus tollens formula rule, which we will then get not R. Then we take the third premise, which is not R imply S. So notice the first word symbol is not R. Before we got a not R too. So we simply just need to use the modus ponens, which we will get S. For the premise 4, we simply need to use the modus ponens similar to the before premise, and then we will get P. So by our answer is D, so we can prove that this argument is valid, since we can already prove that the conclusion is T.
We continue to the next example. We read the argument first. Today is raining and Salwa will go to school by bus. If today is raining, then Salwa had breakfast at home and she is going to school by bus. If Salwa had breakfast at home, then Salwa will play the piano or she will walk to school. Salwa is not playing the piano, therefore Salwa walks to school. So, this is the question for the argument. They have three questions. A. Declare the primitive proposition in the argument using symbols P, Q, R, S, and T. Second, write the premises of the argument using those symbols. And the last one has prove the validity of the argument using the rules of inference. I have highlighted a point from the argument. They have today is rainy, Salwa will go to school by bus, Salwa had breakfast at home, Salwa will play the piano, and the last one, she will walk to school. So this is the conclusion for the argument. Therefore, Salwa walks to school. As you can see, I have circled a few words where we see the word if, and then we use implies. Today is raining implies Salwa had breakfast at home and she is going to school by bus.
To the first question, we declare the primitive proposition in the argument using symbols P, Q, R, S, and T. So for P, today is raining. Q, Salwa will go to school by bus. R, Salwa had breakfast at home. S, Salwa will play the piano. And T, Salwa will walk to school. For question B, write the premises of the argument using symbols from A. So we get P and Q. This is the symbol for N. P implies R and Q. This arrow is the symbols for implies. Next, R implies S or T. This is the symbol for or. And the last one, not S. This is the symbol for not. And the conclusion for the argument is P.
For the last question, they want us to prove the validity of the argument using the rule of inference. So for the first step, we must create a table and divide by 2 columns. Then we enter the first premise, that is P and Q, and we apply the rule of conjunctive simplification and we get P. After that, we enter the second premise, that is P implies R and Q. If you see in number 2 and 3, they have same symbol, that is P. So we apply the rule of modus ponens and we get R and Q. For R and Q, we apply the rule of conjunctive simplification and we get R. Next, we enter the third premise, R implies S or T, and we apply rule of modus ponens because they have the same symbol, that is R, and we get S or T. Lastly, we enter the last premise, not S, and we apply the rule of disjunctive syllogism and we get the answer, that is T. So the conclusion, we success to prove the validity of the argument using the rule of inference.
Okay, now I'm going to show you the third example for this topic. Here we have an argument, P or Q implies to R and S, R implies to T, not T, and the conclusion is not P. So the question asks, by using the rules of inference, prove the validity for this argument. This is the solution. First, we're going to take the second premise, R implies to T, and third premise, not T. Then we use modus ponens on it, on both of the premise to cancel out the T, so we got not R. After that, we want to have S, so it's kind of matched up with the first premise. So we use rules of disjunctive implication and got not R or not S. After that, we use De Morgan's law to bring out the not. So we got not in the bracket R and S. After that, we took the first premise, P or Q implies to R and S. We use modus tollens on the premise and the new premise from the set 5 to cancel out the R and S. So we got not P or Q. And then we bring in the node. So we use De Morgan's law on it and got not P and not Q. Since in the argument the conclusion only have not P, so we use rules of conjunctive simplification to simplify the final answer, and it is proven that the argument is valid. So what we have learned from this topic is that we can learn type of relationship between two or more statements with each other. 2. We able to prove a statement is valid or correct by using rules of inference. And 3. Rules of inference provide us a template or guideline so that we can construct a more valid arguments from the statement that we have and show that the statement is actually correct. So that's it for this topic. Thank you.